Welcome to today's ABC UTC Research Seminar. The presentations in these seminars highlight research work at the ABC UTC partner universities. Each seminar consists of a 40-minute presentation followed by a 15-minute or more question and answer session, and the question and answer session will extend at most to 2:15 p.m. Eastern. My name is Mary Lou Rawls Newman, Director of Technology Transfer at the ABC UTC. I'll be moderating today's seminar. I'll be assisted by Paul Lyles, former Georgia State Bridge engineer, and Jamal El-Kaisi, structural engineer with the Federal Highway Administration, both members of the ABC UTC Advisory Committee, who will be moderating the Q&A session. Ali Javid, Ph.D. student at FIU, will be managing the web room. We're pleased to welcome participants at 300 registered sites for today's seminar. The seminar today features the ABC UTC research project on integrated flood and socio-environmental risk analysis for prioritizing ABC activities, conducted at Florida International University in Miami. We'd like to thank Armin Mehrabi, co-director and director of research at the ABC UTC, for coordinating today's featured research project. We're pleased to introduce our presenters, Ali Ebrahimian, principal investigator, and Nasim Mohamadiazar, Ph.D. student. We'll now begin our presentation. Ali?
Good afternoon, everyone, and thank you for having us here. I'm excited to share some of our results about the project that has been going on over the past 2 years in my research group, and mostly being done by my PhD student, Nasim Mohamadiazar. So as you see the topic today, we're going to be talking about framework or a decision support framework that will support our decision makers to prioritize accelerated bridge rehabilitation or repair activities. So this is for looking at existing bridges and kind of creating a planning tool or a roadmap for how to spend our fundings towards getting the best results. So one of the novel aspects of this research is to incorporate social equity and environmental justice into the process. And we're also looking at we keep the traditional, aspects of the project, looking at structural data, looking at traffic data, but we're also trying to add social and environmental components here. So this is going to be a GIS-based framework, and here what you see is the agenda for our presentation today. I'll start giving you some problem statements, some background, mostly about the relationship between ABC or accelerated bridge construction and flood in urban areas. So this is basically urban flooding. And then I'll be also talking about the relationship between social equity, ABC, and also environmental justice and ABC. And finally, I'll discuss why we really need such a multi-criteria decision support tool here, and talking about the objectives of the project. Then I'll hand it over to Nasim, and through a case study in Miami-Dade County, Florida, she will be walking you through a step-by-step process, and she will let you know how we developed that framework and how we applied that to the bridges in Miami-Dade County. And she will finally present the results of that project, and she'll provide you with some conclusions. And then I will conclude the presentation by giving you some some ideas for the future works and how we're going to be implementing, the results of this project. So I'm gonna be starting with the benefits of ABC or accelerated bridge construction. And really, when we're talking about ABC, it's not just reducing the construction time of our project. Well, these are the language that I was able to get from FHWA. So these are the exact language from FHWA. So safety is one of the important, problems here, and improving the safety through ABC is one big goal here. But as you see in this list here, social problems and environmental problems are also important. So, and there's actually a close relationship between accelerated bridge construction and social problems, environmental problems in urban areas. And if I want to explain that further, is the impact of ABC or bridge rehabilitation, bridge repair projects is not really limited to the work zone of the project. When we are in urban areas, the impact is really going beyond the work zone. And that's where there are interactions with urban communities, and that's where social equity and environmental justice come through. So we're trying to kind of quantify that relationship and see how we can integrate those aspects into our planning. Because one way of going towards the strategic planning and having smarter designs, or having a better use for our dollars, is to be able to get more benefits through whatever we spend for our projects. So the relationship between social equity and environmental justice. Before doing that, or before talking about that, we need to know what we really mean by social equity and environmental justice in the context of urban infrastructure. So as all of you may know, social equity is basically providing equal resources and opportunities by different infrastructure or civil infrastructure systems for all urban communities. And when we say all urban communities, we do mean, for example, the minority groups, the low-income groups, the elderly groups, things like that. All right. And then environmental justice is also providing the same degree of protection from environmental threats for everyone in our communities. So we all know that there are existing inequalities built into our urban communities. There are a lot of studies showing that, for example, when a flood problem happens, those low-income communities are more vulnerable to flood. They can get impacted disproportionately from a flood, probably because of, the type of buildings that they are living in. Or sometimes, for example, you can think about having no personal vehicle to get rid of the problem, or a hurricane happens, then you can't afford, leaving your place, going to in a hotel in a remote area, or things like that. And these are the inequalities that are existing in our urban communities. So what we are doing in these projects, we are trying to identify some of those, problems related to social equity and environmental justice, together with flooding, and together with the structural condition of our bridges and traffic condition of our roads, and see how we can incorporate all these factors into the decision making. And again, in this project, we are only looking at the existing project. So we are looking at processes such as accelerated repair or accelerated upgrades. Starting with flood, basically flood is the most common natural disaster in the whole world. In the US, more than half of the bridge failures, based on the existing studies, is because of this cover due to floods. So as you see, you can imagine that that's the biggest cause of bridge failure in our country. And that's actually a major cause of increased construction and maintenance costs. And that's why our engineers are thinking and are developing new technologies for accelerated upgrade solutions. And that's retrofitting the bridge prior to a flood event, or accelerated repair solutions. And those are the solutions or retrofits that happen after a flood event happens. And the relationship between ABC and flood, I think, is that simple. Flood can disrupt traffic flows, and floods in urban areas can damage bridges and roads. And we need to put them back in operation as quickly as possible. In some cases, there are some water works. We need to divert some waters from the project work zone if there are streams, if there are rivers in that area. And then flood can also happen during the construction, during the repair process, during the upgrade process. And by using accelerated bridge construction techniques during the repair process, we are actually reducing the risk of damages to the bridge, and also the possible damages to the construction equipment, as well as the possible injuries to our workers. So that's the close and clear relationship between ABC and flood. So then talking about social equity, there are a lot of aspects that can be considered here. And I'm just giving you just a couple of examples here to let you know how there could be a relationship between ABC and social equity in urban areas. Well, first of all, people or urban communities, they're the end users, the final end user of our bridge projects, okay? And people need to have access to their vital services. So we're talking about the accessibility to their jobs, they need to go to the works, they need to go to schools, to universities, they need to go to hospitals when needed and as quickly as possible in sometimes, okay? And then that's something that's a basic need for urban communities. On the other hand, a lot of construction projects, including bridge construction projects, can cause disruptions to traffic flow, to businesses, and to residents. And basically, as someone who lives in an urban area, we are not, that much happy with seeing a lot of construction going on in our neighborhood. I don't like to see a lot of trucks in my neighborhood, a lot of noises in my neighborhood due to the construction projects. And these are things that are coming with all of the construction projects, especially the longer periods of construction that may be the case for bridge construction. Okay, and then we can think about a lot of other relationships. For example, thinking about the high crime rate areas, there's chance of vandalism and theft of construction equipment and materials in those areas. There are documented studies about that show that these things can happen. I've personally been involved in road and bridge construction projects with these sort of problems in urban areas. And these problems can further delay the construction process, and they can increase the insurance costs of our projects. In some cases that could happen, and there has been examples here in our country, legal investigations can happen due to those sort of things, and sometimes they can, those legal investigations can even stop the projects to kind of investigate thoroughly the problem. And these are additional, a relationship between these social aspects with the construction time of the projects. So how ABC can be important here and can improve the situation here? Well, basically, if you use accelerated techniques for upgrading for your repair process, you can provide the vital services for mostly for those low-income communities. So the project time is shorter, so they can get access to the services that they want in a shorter time. Then the reduced project time also results in the reduced chance of theft or vandalism. That's another fact. And even those, like, I would say, I don't know if these are rare cases or not, even if those legal investigations happen and they want to totally stop or pause the project, where the construction projects will be less impacted because a lot of activities will be offsite using prefabricated, for example, elements by using the ABC techniques. So these are just some examples of how ABC can help improving the social equity in our urban area. And same kind of relationship, but this time with environmental justice. So you can think about, for example, air quality as a threat to both the workers in the work zone and also the urban communities adjacent to the project. Okay, how about the extreme heat? Are you living in an area such as us in South Florida, in Miami? Extreme heat is an issue. There are a lot of loss of lives due to extreme heats, and these are all documented. So extreme heat is actually a threat to our workers in the work zone. And basically, by using ABC, we are actually reducing the exposure of our work zone, and in some cases, our urban communities, to those environmental threats. And that's the clear relationship between environmental justice and ABC. So now, the last thing I want to discuss here is, okay, we are able to identify those relationships, but why do we need a multi-criteria decision support framework to help our decision makers, if that is FHWA, if that is our state DOTs, to come up the best plan for allocating funding selecting projects that are most eligible for repair or rehabilitation stuff. So basically, there are more than 600,000 bridges throughout the country, and according to FHWA, more than 25% of all these bridges need some sort of rehabilitation, repair, or in some cases, total replacement. Well, obviously, we have limited budget for doing that, and then there are a lot of criteria to be considered in the problem. Well, I talked about social equity and environmental justice, but these are in addition to the basic criteria, the structural criteria, the traffic criteria, flood-related criteria. So this is really a complex problem, and to be able to support our decision makers to have a better plan or to come up with the best plan about the project selection, we do need to have this multi-criteria decision support framework. The objective of this work is to develop such tool, a tool that can help us, that can provide us something that I just mentioned. So this is going to be a risk-based tool, and this is going to be a GIS-based tool because we are looking at multiple bridges in a region. This, by a region, this could, for example, our case study, we demonstrated the application of this tool to the bridges, the existing bridges in Miami-Dade County. But the area of interest could be flexible. It could be part of a state, it could be all of the state, it could be a county, it could be even part of a county, depending on who the decision maker is and what the jurisdiction of interest is. So the decision support tool, the decision support framework, basically, that we are talking about here, well, first of all, it should be simple to be able to be used in real applications. And I will be talking about that in the last slide, that how we can make it simple enough for example, our state DOTs. And then it needs to be systematic and adjustable for different projects. If you want to use that anywhere for any area, then it should be adjustable. Then it should be GIS based because we are not just looking at a single bridge, we are looking at multiple bridges depending on how large our area of interest is. Well, if you want to use that anywhere in the country, it should the data that we use should be readily available, and that's something that we have paid attention to in this project. And finally, we understand that even if, for example, a certain state DOT is the decision maker here, there are probably multiple groups in that organization that are decision makers for that problem. And then the tool is able, or this framework is able to handle these sort of situations where we have more than one decision maker in the process. So with that, I'll hand it over to Nasim, and she will be walking you through the development process for this framework. Nasim, it's all yours.
And thank you so much. Hello, everyone. I will discuss how we develop our framework for prioritization of the existing bridges and develop our framework through a case study, which we decided to have Miami-Dade County as the case study. And we choose Miami-Dade County, not just because we are living here, which seems a good reason, but no, that's not the only reason. It's because this is a good representative of low-lying areas on the south coast of the United States, which is exposed to the high risk of flood and storm surge. And also, considering the social environmental issues, Miami-Dade County, with a population of about 2.5 million reported in 2021, it has a large amount of exposed assets and, of course, road networks and bridges and population vulnerable to, for example, like the sea level rise, flood, and this kind of issues in the world. So for the case study, we look at the urban area specifically because we are working on the existing bridges, which are already available on the urban area of Miami-Dade County. And so we collected the data for the bridges and also the area for the flood and social environmental factors. And overall, And the total number of bridges we took into account and looked at them for developing this framework were about 986 number of the existing bridges over Miami-Dade County urban area. So in the traditional way and traditional method, which I'm discussing about how mostly decision makers try to use and different kinds of frameworks to prioritize the bridges and support the decision making. They mostly and traditionally they just look at the bridges or structural condition of the bridges and only traffical condition of the bridges. And this resulted in ignoring other essential factors such as flood and social environmental vulnerability areas. However, it developed a special multi-criteria decision analysis tool or framework to integrate multi-criteria and provide risk map that not only takes these two factors, but also it considers other factors, as we discussed, as flood and social environmental. And to generate our map, we input the layers and pre-process the data together and reclassify them based on their initial thematic value. And the risk map is the output of the set of the maps that are the result of our analysis, and we overlay them together.
Here you can see that how we decided to choose different kind of data and how we collected, how we ended up to a different kind of data we use for this framework. And as I mentioned, this is not just looking at the like national data, but also you should be more specific and consider like region-specific factors as well. For example, I want to give you an example so to make it more sensible. So this is different from this is different for every region to have different kind of data. For example, like when you are looking at Miami-Dade County, it is like for sure you're looking at flood issues or hurricane evacuation zones that we consider here. Annual rainfall is important here because again we are looking at the data related to flood, but it could be different for other regions. And it's essential to customize your data and the collection of data you have based on your region and your study area. And this is helping you to develop a more accurate and effective risk map. And like again, this category categorized figure showing you how we have different categories under environmental, physical, social, structural, and traffic condition. And next, okay. This is a distribution of physical data we use, and this distribution is a color-coded map to visually convey the distribution of pattern of each data over Miami-Dade County. And the colors represent different values or ranges of values for the data being analyzed in our research. And this is good because this makes it easier and better representative for viewers or decision makers to understand and interpret the data. For example, you can see here, like in hydrologic soil group type, how different and various hydrologic soil group we have in Miami-Dade County. And in the next step, we needed to have them categorized from very vulnerable to very low, very high vulnerable to very low vulnerable areas. And in order to that, each data based on the categories reclassified and analyzed to have these different categories. And the classes range from very low to very high, which with the corresponding color coded cells indicating the degree of vulnerability for each criteria. And this classification processes providing a more detailed understanding of the risk of the bridges or the area So you can quickly identify the area of high and low risk, and this will help easily to prioritization of the ABC projects. And then we also had social factors and social data. And to classify the social factors, we collected the data related to population demographics, such as age, such as income, population density, and so on. And then we classified them into 5 different risk scales, ranging again from very low to very high, to understand and potentially have a better visualization of our interpretation of the factors over the area. And similarly, again, to classify the environmental factors, we have different data under environmental category. And you can see that we decided have to heat index for Miami-Dade County. And heat index is a measure of how hot it feels when relative humidity is added to the actual air temperature. And it is really important that consider this should be customized to your region. So as I mentioned, like it might be different for other regions. And similarly for air quality index, which is a measure of air pollution and how it can affect human health. And this category is derived from EPA. And again, I want to emphasize that be aware that while using heat index or air quality index, although they are important to consider and evaluate the vulnerability of the bridges, they may not be relevant in all regions. So, for example, in some regions, in a cold area or during winter, wind chill index might be the better option for choosing to consider in the framework. And again, like the other categories and data, we reclassified them to have all of the data in the same category from very low to very high vulnerable, so we can process them and analyze them for extracting the the risk maps and vulnerability maps. And then here you can see that after like overlaying the data all together and putting them on top of each other, we have 3 different vulnerability maps and fraud risk map, which are related to environmental vulnerability, social vulnerability, and flood risk. And each of them is extracted from overlaying the layer on top of each other. And again, these maps, this integrated map is a color-coded map from very low to very high risk areas. For example, here you can see that red color is associated with very high and very risky areas in Miami-Dade County. Dark green areas, they are good. Like you, obviously, not many attention might be focused on these regions because they are not, in terms of like environmental factor, they are not so much at risk. And unlike social and environmental factors and maps that we extracted and we got the data from surveys and field visits, flood risk maps need some kind of validation. So to make sure that the accuracy of the flood risk is satisfying. And for this step, we decided to have reported fraud events against available flood events. And this was done by mapping the location of historical flood areas using flood reports. And it's really a challenging step because there isn't a comprehensive data sets for getting these historical flood events. And so this is really important. And finally, we got some data from Institute for Environmental Studies, which is monitoring over 200 local floods for Miami-Dade County for every year. And this is the online data sets that got the data or the reported flood zones, flood areas based on social media or Twitter tweets that people mostly posted them because they have or they see some kind of flooding issues on their communities or neighborhoods. And this is specifically because of heavy rainfall, which is because we are looking at the floods caused by rainfall in our framework. So we use these reports to validate the accuracy of our flood map. Our flood map obviously was generated by the physical data. And then the other step is that you can not only using the social media or this kind of historical flood events posted on the social media, you can also use satellite images. For example, here we specifically used Sentinel data satellite images, and then we integrate these satellite images with the reports or the specific locations that people posted for flood events on Twitter. To make because of extracting the exact locations and to make sure that the flood events are not confused with, for example, like breaking in the in the pipes or something that is not rainfall floods. So the quick review on how we process that is that we extracted the Sentinel data for the specific time that we extracted from social media, that we are sure that in that time we had the flood event. So we extracted that Sentinel data and image for this specific time, and it's again a challenge because you cannot make sure 100% you have the satellite data for exact time that the flood happened, and you it obviously take a lot of time to compare the times of the the satellite data they are captured and also the flood events that you are sure they happen. So to make sure that the image you're extracting, they are accurate and they're exactly for that time frame. And then we pre-process them to just remove the noise, like the thermal noise or anything like a cloud or anything like that, and calibrate them to make it possible to use for the validation. And this is the result of the validation. Like you can see, like I provided some examples here for you to see that how the different areas can be affected by like the very high vulnerable areas prone to flood. For example, in Miami Beach, you can see these red areas are affected with the historical flood events. Sorry, with the very high vulnerable they are very high vulnerable areas for the flood. And again, like you can see that the flood reports and also our flood historical map that extracted from satellite data can explain the accuracy of our result for the flood risk. And here is a quick note I wanted to mention because it's important. Kind of this step may not be like as visible as other aspects or of our methodology or framework, and this is essential in ensuring that our risk map is reliable and can be used. So without this step, there is a risk that our risk map might not be accurately reflect the actual flood vulnerability of the bridges in the study area or the urban area. And so this is behind the scenes and typically carried out by the research team responsible for the developing the map. So final users, they are not responsible or they don't need to directly validate the risk map by themselves, and they may not want to, or they might not require to take this step by themselves. And so far, we look at the urban area and the risk factors, high risk areas. in the urban area, specifically in the urban area of Miami-Dade County, considering physical, social, and environmental factors. But on the other hand, we have the traffical and structural condition of the bridges on this in this area. So I want to explain how we got these data, how we analyze them, and extract the risk map here for you. And just a quick reminder, we have traffical and structural data for our bridges, which are the existing bridges, and we use them to integrate with the already risk map from area. And the data are for the structural, we consider the age of the bridges, the scour condition of the bridges, and sufficiency rate of the bridges, which comes with average daily traffic, which is annual over the bridges, and traffic accident, which means the car crashes specifically over the bridges or the area we are studying. And here you can see as the other data categories we have different values and classes for each of these data. And again, we reclassified them to have the same classes for overlaying the data on top of each other. And for the structural data, you can also see the how the distribution of the age of the bridges, scour, and sufficiency rate of the bridges are over Miami-Dade County existing bridges. And then again, that's the same step for the data here. And in the next step, we extracted two different integrated maps. One is for traffical risk, and the other one, the structural risk of the bridges, which means that if you remember, we had different traffical condition of the bridges, like the accident and ADT, average daily traffic. We overlaid them together and also to extract this map. And again, for the structural, scour, sufficiency rate, and age of the bridges, they were overlaid and integrated with each other to have this structural risk, which is conveying how the risk is distributing, combining, and integrating all of those factors with each other. And here I will be discussing the design of scenarios for the risk assessment of our framework in the context of evaluating the risk of the bridges. This is the representative scenarios including in our analysis, and this is based on certain assumptions for the weights of criteria used to develop the risk map. And this is because we are already using like a bunch of data, and they don't have the same importance, or like decision makers might decide to have different weights for their for each of these criteria. So this is conveying how we can put these weights for each criteria and each category. And I want to mention that we have different approaches to have weights. For example, like AHP, analytical hierarchy processes. But here we just wanted to show how different scenarios or how different approaches can work. So this is crucial for final users to understand that the scenarios presented here are only representative and may not necessarily reflect the optimal weighting of criteria for any kind of specific situation or area or bridges. To evaluate the risks of bridges, we use different scenarios. You can see here scenario 1, scenario 2, and scenario 3. And in each scenario, we have different kind of situation and weights. You can see here that scenario 1 represents the traditional prioritization approach, which consider only the traffical and structural condition of the bridges for the decision making framework. And this is widely used by many decision makers, such as like a state Department of Transportation, to prioritize the maintenance and repair efforts. But in the second scenario, we not only look at the traffical and structural condition of the bridges, but also we add flood factors. This scenario aims to provide a more comprehensive and holistic approach to risk analysis, taking account these three factors together. And in the third scenario, which I call it a more comprehensive scenario here, is not only taking account traffical, structural, flood risk, we also look at environmental justice and social equity factors. And so these weights could be different. For example, the scenario one weights, like after having discussion with our advisory panel, we decided to have these two weights for traffical and structural factors. And here you can see the final integrated risk maps that show how the risk level over each bridge can be different or be distributed over Miami-Dade County. And I'm starting with scenario one and explain that for you first. In scenario one, as I mentioned, the risk map shows the location of vulnerable bridges based on their structural and traffical condition. And existing bridges were determined to be moderate to very high vulnerable based on the age of the bridge or average daily traffic, car crash rate, and sufficiency rate, which is the bridge's risk level, and it's unique for each bridge over Miami-Dade County. And this is measuring the bridge's risk not only because they are like having high rate of car accident or average daily traffic, but also like if they are in a like a bad or worse structural condition. And the second scenario, flood risk, was added to the first scenario. Bridges along Miami-Dade County. You can see like here in some bridges along Miami-Dade County's east coast from south to north showed high risk vulnerability, and they are categorized as very high. And this is like the effect of how flood can affect risk distribution on every bridge. And in the third scenario, you can see that social equity and environmental justice affect on distribution of the risk value for each bridge when we consider structural, traffical, integrated with other factors. And as you can see again, like you can see this road, which is I-95. The distribution of the risk is kind of changed, and this represents that bridges that were considered very high, for example here, or kind of very high, like high risk factor, when considering social factors and environmental justice criteria, they turn to medium level. Although we have other bridges here, which is categorized as medium or very high risk level, considering flood risk, social and environmental justice factors, they turn to very vulnerable and very high risk bridges that need to be considered for accelerated bridge construction. And you can see that the bridges located in the east side of county, they are in the medium and high risk condition. And this is really beauty of our framework that allow us for incorporating new criteria as we needed. By adding new criteria, we can compare the results with each other. And I want to show you here that how risk distribution differ from scenario 1 to scenario 3, and how each risk level can be differ from each other when we introduce new factor. And this feature of our methodology is particularly valuable because it allows decision makers to continue to refine and improve their decision making process over time. And as new data and information become available, they can update the framework because it's systematic, and they can modify to incorporate the change and see how the result might be different. And this is the beauty of this work. For example, if a new social environmental factor emerges as important for bridge maintenance and rehabilitation prioritization, we can easily incorporate that factor in our decision-making framework and observe the result, how the result can be changed. And this might be really useful when you have limited budget and you have many bridges. They are in the process of rehabilitation or having some updates, and you can use this framework to support your decision making, because the final risk level that you get is unique for each bridge. And that can be helpful when you are facing limited budget and you want to make a decision for your allocating your budget. And this is just a quick summary to show you how we develop this framework. We have initial layers, as I mentioned, and like I'm emphasizing on that because this is really important, because I don't want you to think this is a solid work and you can change the data. This is a systematic framework. You can update it. You can consider different criteria based on the importance of the criteria in our study region. So you extracted the initial data and integrate them together, which is again the work of the the research, people who are working on this framework, not something that decision makers do. And then we already use the multi-criteria decision analysis, as I discussed here, to extract the risk factor for each bridge, which is a unique value and a unique number or risk factor for each bridge. And at the core of our methodology, at the end, I wanted to emphasize the core of our methodology, which is considering social equity and environmental justice integrated with structural and traffical condition of the bridges. And we aim to address this historical inequality and create a more equitable framework for supporting the decision making. And our approach recognizes that factors such as flood risk or structural conditions can impact the prioritization change over any study area that any bridge might need. However, we also recognize that social and environmental factors such as income or air quality can further exacerbate the vulnerability and impact the communities and bridges risk level. And by taking a more holistic approach to decision making and considering all of these factors together, we created a more equitable and systematic prioritization decision making that every communities needs to have those equity and justice. And our decision support framework is designed to provide particular tool and guidance to transportation department to help them prioritize the accelerated bridge rehabilitation projects in an inclusive and equitable manner. By using this framework, Department of Transportation can take into account various factors and that impact their bridge safety and communities, and make informed decisions that benefit all the members and the communities. Ultimately, by incorporating social equity and environmental justice into infrastructure planning and development, we can create a more inclusive and suitable framework for future. And I want to go back to Dr. Ebrahimian for a quick implementation.
All right, thanks very much, Nasim. Implementation opportunities of this project. Well, as Nasim just thoroughly explained that for you, we are using readily available data, so we are expecting that this work can be applied anywhere in the country where we have the data. And then the decision support framework, as you saw, is really structured, flexible, and adjustable. That means that if you feel like, hey, there's another criterion that's important, no matter if it's about the structural condition of the bridge, about the traffic, about the social aspects, whatever that is, you have the opportunity to include that in the framework. And if you saw something here, the criteria that we introduced here was actually for our study area, so there might be no need to use some of them for your own area, so we can easily remove that. So this is like a very systematic and flexible process. We do have systematic approaches and procedures for determining the weights of criteria or relative importance of criteria based on the preferences of the decision makers, but we just wanted to show you that this this method or this framework is able to consider different weights. So those scenarios that you saw was for that reason. And finally, we are hoping that we are able to attract some funding to go to the next step of the project, which could be of use to FHWA and all of the state DOTs, basically, to kind of go to the next step and develop an online tool that can help to do automatically all those steps. So all you need is to define your area, define your criteria of interest, input your data, and then everything else will be done by the tool for you. So we do have a lot of examples of online tools nowadays being used by different federal organizations or state organizations, and this could be a very useful tool in addition to the existing ones. So with that, I would like to thank you all. I would like to thank you all for listening to our presentation, and I would like to especially thank the Accelerated Bridge Construction University Transportation Center at FIU and our colleague universities for providing the funding for this project, and we are looking forward to the next steps of the project. Thanks very much. And here are our contact information. So if you have any questions today, if you don't have a chance to ask your question today, please feel free to reach out to me and Nasim. If you have comments for the future works, we are more than happy to talk to you further. Thank you.
Thank you, Ali and Nasim, for your interesting and informative presentation. Paul and Jamal will now moderate the Q&A session. Paul?
Okay. Ali and Nasim, thank you. It's interesting. We do have some questions that came in during the presentation a little bit beforehand. Let's get ones that came in earlier. And the first one we have here is the intensity or the volume of a 100-year storm runoff likely to be increased in the future?
Well, that question is not really directly related to this project or to the work that we did here. However, I can provide an answer for that, and that's something that I usually teach in my water resources class. So looking at return periods of floods is actually based on flood frequency analysis. So for that, we are looking at the historical flood data, And we are basically looking at the chance of exceeding a certain amount of flood in a year. So, well, I don't know it's the nature. I don't know what's going to be happening in the future, but if we do see like larger storm events more and more in the future, yes, there's a chance that we do have larger values for our 100-year floods in the future.
Okay. Here's one. Did you include demographic analysis in the study?
So I guess the simple answer is yes, and whatever Nasim mentioned. So do you want to add anything, Nasim, here?
Yeah, I wanted to say that, yeah, we use them.
Well,
Okay.
all of the social data that you saw, I guess we had about 6 maybe different data sets. So they were all based on social demographic factors.
Okay. To implement this framework at different geographic locations, the factors like land use, precipitation, and temperature should also be incorporated. What are your thoughts on that?
Well, they are already incorporated. So as you see here, under the physical or flood-related data, you do see that we have land cover. For example, here we have rainfall, here we have imperviousness, and these are basically the factors that are important for flood generation or rainfall-driven flood generation in an area.
Okay. Here's an interesting one. How readily available is the use of air and waterborne drone technology to collect structural, hydraulic, and environmental data?
Well, that's an interesting question, but I don't think I'm eligible to answer that because that's not my expertise. I have been involved in some projects where we use drones for collecting LiDAR data, but I have seen a lot of studies, people using drones for collecting different sorts of data. But again, I have not been directly involved in implementing these sort of projects.
Okay, here's one on how do you manage compound floods?
Oh, well, that's a very good question. Although, again, how to manage those floods is not what we're doing in this project. But to give you a quick response on that question, well, compounding floods are when we have more than one driver for our flood. So most of the stuff that Nasim mentioned in this presentation was basically looking at the rainfall-driven floods or pluvial floods in urban areas. However, there might be other drivers for flooding in urban areas. For example, if we are in a coastal area, storm surge could cause coastal flooding. Sea level rise could be another issue that can be, increased because of climate change and stuff like that, and also extreme rainfall event. So these are different factors, these are different drivers, and if some of them are happening together or quickly after each other, they can create compound flooding. So in this project, well, basically we are not doing flood modeling here because that has its own issues than the validation stuff. And we are just creating a planning tool, and we are trying to keep it as simple as possible here. So the way we address this issue here is, if you look at, and that's a good coincidence, we have the right slide here to explain. So just look at the physical data here. So we do have, for example, the depth to water table. And for example, thinking about sea level rise, one of the consequences of sea level rise in coastal areas could be elevated groundwater levels, and that can help with creating floods. So the way we included that here is just looking at the depth to water table as a criterion here. We didn't directly consider, for example, storm surges here, but we did look at the hurricane evacuation zones, and we considered that as a criterion here, and also with the annual rainfall that could be related to having extreme storm events in an area. So these are the things that, again, we were trying to keep it as simple as possible, but yes, you can definitely make this more rigorous, but then you should keep in mind that, you know, how we want to keep this framework practical and, you know, usable by the end user. So that's another issue. But then about your question, I guess the question was about how we can manage the compound flooding. That's a whole different, you know, story. But there are structural and non-structural practices for managing compounding floods. And for example, I personally am working on mostly on nature-based solutions using green infrastructure to address those sort of issues. But there are a lot of other, you know, gray and green infrastructure besides the non-structural practices for doing that.
Okay, we had a question here on slide 10. What role does economic impact or first responder services access have in the decision-making framework?
Nasim, do you want to go with that?
The question is about environmental justice, yes?
Economic impact or first responder services.
Okay, I see. Well, as we mentioned that it's kind of like all of these factors have two sides. One is like that factor is causing or making the situation worse. On the other hand, the situation which is in a like is exacerbated can influence on the cause, also like not time, also the money or the delays. So they are all something that can affect on the economic aspects of the project.
And I can add a little to that, thinking about the first responders. What we have here under our social data, you do see the land use here. What we mean by land use is here, we sometimes have some, I would call it important places for this study. And those are, for example, fire departments, hospitals, shopping centers, like big malls. So these are the areas that are more important, because if something happens, if a road closure happens in that area, there's going to be a lot of people who get impacted by that. So we should pay more attention to those areas. So I can include, I would say, this matter or this issue that was brought up in that question can be kind of addressed by using this land use here under the social data.
Okay. You might want to go to one of your maps, just your slide with all the different maps.
Okay.
And the question came in was, how were these GIS maps gathered? And then was it an existing data source that was available?
Okay.
And then what is the data source?
Yeah. Well, at this point, like, yeah, in the future, you can find that on the report of the project which is published, because at this time we haven't published it yet, so we cannot provide the like the actual source, but they are readily available. For example, like for some of them, for imperviousness, you can download them, but for the other ones, for example, the distance to channel, they are not directly available. You just need to extract or download the network of the water bodies or channels, and then using the GIS tool, you can extract that. So this is something that you need to work on that, or for something like depth to water table, you can like directly download it. So based on the data you have, it's different.
All right, and the final part of this question.
And Paul, I can probably add a couple points to that. So I actually noticed that Nasim is not disclosing the sources of data because she's trying to publish this, and that's okay. But the good thing is our final report will be out in a couple of months. It's in really final stages of development. We have finished the final report. We are working on the comments that we have been receiving from our technical advisory board for this project. But a quick answer to this question is we have used national data sets and also state data sets. For example, for land cover, the national data set, or for imperviousness, that's the National Land Cover Data Set, NLCD. and they keep updating that. But the data that they are providing is in 30-meter resolution. So a lot of time, different states or maybe different state organizations, they create their own, for example, land cover data with a much higher resolution. So you do have the option. In the final tool that we are thinking about, it has two stages basically, or two levels. One could be, which is pretty, I would say pretty doable, is having a tool. First of all, you will select the data that you want to work with, and then you go ahead and use the best data that you have access to. It could be from your state or it could be from your national data set, and you could incorporate it into the tool. The other thing that could be the next level is just to say, hey, I need this data and this is the boundary of my area, and then the tool can go and get access to the best possible data. So this is the highest level that I can think about the future of this tool. But in any case, we made sure that this data, at least there's a national database, even if there are much higher resolution data at the state level or sub-state level, but at least there are some national level data available for all the states here.
All right, that was the final part of the question, was, is it available for other regions of the country?
Oh, definitely, yes. That was a big concern for us. We wanted to make sure that even in coarser resolution, such as the example of land cover that I just gave, we wanted to make sure that we do have at least that data available in any part of the country. But I'm pretty sure, again, for that example, for the land cover and for land use, of course, there are usually most of the states and some of the, for example, in our case, Miami-Dade County, they have the open data hub, and it's freely and publicly accessible. So you can go there and you can select whatever data that you need. And this is what exactly we did.
Okay. It's about 11 after. I'm going to ask Jamal to come in if we have any questions. I think I got most of them answered, but two. But Jamal, do we have any questions you want to pick up?
A good presentation, Ali and Nasim.
Thank you.
There's a couple of questions that been put in the questions here in the question area, but then it was withdrawn because Nasim answered the questions in the following slides. So if you want me, I can ask these questions, but it seems like you covered them, Nasim. One of them covers the weights, which you covered in slide 32. And they're talking about the multi-criteria weighted for the integrated maps. And the person that asked the question, he, I guess, understood the concept of weights, and he took the question out. But if you wanna cover more about this weight, it'll be all right too.
Nasim, you want to go ahead?
Yeah, of course. So like, as I mentioned, there might be different approaches to have different weights. One is like hierarchy analytical approach, and or the other one could be like having a questionnaire, so sending different questionnaires to decision makers or people who want to be have some influence on the decision making, and then apply based on those like survey or questionnaires how to define the weights. But again, this is just a representative scenario, so it could be different, and based on every region, it could be different. This is not the solid frame, like the solid weight that like tied to your hands to not change it. So, yeah.
Okay, good, Nasim. And there's a question, Nasim, about the political weight often overrules the technical factors or analysis. Again, this question was withdrawn because you mentioned about the implementation. Ali covered the implementation page, which allows for weighting based on preferences.
Mhm.
So he took the question out. But if you want to address the political, this is not a question, but it's a statement. It's
Yeah,
a
well, yeah,
overrules.
yeah, I can give some more thoughts on this. Well, basically, I understand that. So that political aspect is basically part of any decision making in real life problems nowadays. Okay, so what we are doing here, we are not the decision makers. Okay, this research team or whoever the research team or the project team is, we are not the decision makers. We are just trying to support the decision makers. We are just trying to let them know, hey, what is the consequence of the criteria and the importance of the criteria that you are thinking about? Okay, if you are thinking about these criteria in your problem, this is going to be, the result. If this criteria is more, if this specific criterion is more important than the other for you, that's okay. This is the final risk map for you. And the interesting thing with that risk map is it's really practical because that gives you a simple risk factor for each single bridge. So you can see, for example, the bridge at the intersection of I-95 with that specific road. All right, what is the risk factor for that specific bridge? All right, and this is based on the criteria that you chose. Okay, so you see the result. You're not happy with that for any reason, and you feel like, hey, this is okay. That's okay. We can get back. You can reimage the process. You can say, hey, I'm gonna include this factor too, this criteria too. That's okay. We can do that because this is like a very flexible framework. And then you can let us know, how important that is for you. Even if you're not at the situation to provide us with your actual weight or a solid weight for each criterion, we do have methods because well, I personally have worked in many practical problems, and in a lot of time that's true, that a lot of decision makers for many reasons are not well, they're not comfortable or they cannot provide their preferences clearly, okay, because of a lot of reasons. It could be because of political reasons, thinking about the consequences, or sometimes the decision maker does not have enough knowledge because they know that this is going to have consequences. So that there are other stuff, and I have personally done that in different projects, is we can do different procedures. We can create like questionnaires asking you just questions, and then we can do some sensitivity analysis to come up with some recommendations that kind of could represent your preferences. And then even if you have different people, we can use a group decision making tool. So these are all the stuff that can be incorporated into this tool to address that aspect, like the political aspect or issue that was correctly brought up by whoever asked that.
Good answer. And that's all the question I have. Ali, again, and Nasim, great job. Good subject and relevant topic. Back to you, Marilu.
Okay, thank you. Thank you again, Ali and Nasim. Great job
you.
for sharing your ABC research work at Florida International University. For your thoughtful responses during the Q&A session, this has been a really good session. Thanks also to Paul and Jamal for moderating the Q&A session, to Ali for managing the web room, and to all participants for your attendance and questions. We appreciate your interest. Our next quarterly research seminar is scheduled for Friday, July the 28th. Details will be posted on the ABC UTC website as developed. This concludes today's seminar. Thank you.